Hey y'all, welcome back to the Hack Shack. Today we've got another fresh box from the folks at Hackerboxes. This is Hackerbox 97 and the name is Ringer. Let's get this on the bench and see what we have inside here. This is the Max 4466 amplified microphone module. This is the remote for the Bluetooth RGB LED controller. This is the YC 1166 based Bluetooth RGB LED controller. This is the ESP32 Wi-Fi dev board with the CP2102 USB chip. These are some female DuPont jumper wires. This is a 3-pin JST SM paired pigtail set. This is a USB-A 3.0 extension cable with braided nylon jacket. Nice extension cable here. And here is why I think this Hackerbox is called Ringer. Looks like we've got included 10 addressable RGB LED ring boards with 256 total pixels between the one I just opened and this one I'm fishing out right here. This is the exclusive dark side of the LED sticker from Hackerbox. Pretty cool. And last but not least, our Hackerbox 97 collectible reference card. Before we move on, I'd like to take a moment to thank today's sponsor, PCBWay. Did you know you can get custom PCBs made starting at only $5? And in addition to their PCB prototype service, they also offer PCB assembly, CNC machining, 3D printing, sheet metal fabrication, and injection molding services. At the time of recording this video, there are some great sales going on for Black Friday at PCBWay. As of December 1st, these will continue on through all kinds of Christmas sales and coupons. Make sure to check the link in the description. We thank PCBWay for being today's sponsor. As they always do, the folks at Hackerboxes have provided a great set of instructions that go with this Hackerbox on Instructables, and I'll be following along with this as we go through. Make sure to give this a look. Even if you don't have the kit, it's got a lot of great links and good information in it. As you can probably tell by now, this is a very heavily focused, addressable RGB LED kit. There is a cool link to a video I'll make sure to include, and it's also on the Instructable page that goes to the manufacturer of these type of LEDs, and that's pretty cool. I think you might find that interesting, so make sure to check that out. Alright, let's get ready to build something here. Now what we're going to start with first is soldering up this set of rings here that we're going to leave attached together. We're going to do it like this so we can follow along with the Instructable as it goes through the exercises. If we take a little closer look here, you can see how these are almost like, imagine those LED tapes that are flat and long, like those that are bent back on themselves. And notice how the ground and the power is continuous, but there's a small break there between DI and DO. And the DI is data in and the DO is data out. We're basically going to come in from this left side here with our connector that we're going to solder on, just like the previous illustration showed. And then we're going to connect all our grounds together from the different rings and connect our 5 volts together from the different rings. And then we're going to kind of cascade the data outs to the data ins and stair step down to the smallest ring. Alright, so right here I'm just going to load up the pads, this first 6 pads with a little solder. Now I'm going to use a little bit of a blue tack to hold this connector in place, and I'm going to solder these pins. Sorry, my fingers are in the way. That'll happen a bunch on this video. Take my blue tack off there. Then I'm also going to put my first little jumper in place. You can see that's going in right there like that, and I'm going to load up some more of these pads down through. Some of these I actually don't end up using, but I'm loading them up anyway. More jumpers here, and as you can see, I've got just and you'll see later, I'm just going to have one color jumper. So, you know, if you do this, you can decide to use some different color jumpers. If you use the same color jumper, just be very careful. I'm clipping some excess there, trying to make sure nothing shorts there. Adding my jumper. That's the last of my 5 volt jumpers there. I'm going to strip off some more little jumpers, and then I'm going to start working on loading up these pads, trimming some excess there, and then you'll see I'm going to start putting the jumpers in for all the ground connections all the way down to the largest ring, from the largest ring to the smallest ring. Next, I'll start doing my jumpers for the data in and data out, going from largest ring to smallest. Just kind of working through those guys. I get all the way down to the last one and clip off the excess, and there is the completed solder job. You can see how that compares to what we were trying to go for from the drawing at the beginning there. And a quick reminder, this hookup wire is not included, so if you're going to do this kit and you don't have any, you might want to pick some up. Alright, so the first way we're going to try to manipulate our LEDs is by using this pre-made Bluetooth controller. We use this extension, and there's the controller. And again, the back of this is exposed. Make sure the surface area is clean or insulated, because the back is open there and you don't want that to short out. So make sure your surface is clean, flip it over. You're going to plug this extension into some USB power or into your computer for power. Then all you have to do is just connect up the JST connector there, and the default programming on the controller should start right away, and you should be able to see something happening. If all your lights are lighting up at that point, you should be pretty confident that your soldering job was okay. Next, I tried out the remote. First, I had to pull out this little piece of plastic insulator there that keeps the batteries from, I guess, discharging while it's in storage. And then you can press the buttons. I think that was off and on. And you can see I'm going to cycle through several different little settings here. And that's just kind of showing that the remote works. So that seems to work just fine. And here I'm trying the physical buttons on the little controller box, and that cycled through different things as well. No problems there at all. I then checked out the app that controls it over Bluetooth. You know, I'm assuming it's not sketchy if it's in the Google Play Store. Do what you'd like, but it did make the lights change and had some different controls and stuff. So no complaints there, but you know, you do what you want to do and what you feel comfortable with. Now, one quick thing I wanted to say about this controller. Some folks may not like this, think it's like too simple and not tinkery enough. But I think this is good for two things personally. One, it's a nice thing to play with LEDs for someone that doesn't want to get too technical into the weeds with them. And the second thing I like is a way to have just as a test device. Recently we did a workshop where we were making a bunch of LED strips for a project for folks to work on. And we were cutting up pre-existing strips. And then we needed to test each one after we re-terminated the connections. And something like this would have been nice to have to quickly test those things with without, you know, using one of our ESP devices. And it also could be good for troubleshooting, I think. Like if you've got some problem with an existing setup, you can pop this thing out and it will tell you real quick if your micro is having an issue or your cabling or the LED strip is bad. All right, now it's time to start messing with our ESP32. This is a nice little module, and it already has the header pins attached, so we don't have to worry about that. That will be handy when we make some jumpers out of those DuPont headers I showed you earlier. This particular board needs a micro USB cable. Now you'll need to supply that yourself. One is not included in the kit. And just like the documentation says, the first thing we're going to do is make sure that we see a red light when we hook this thing to power. I saw the red light, so now I'm going to move on to configuring the Arduino environment for the device. So the first thing I'm going to do is go to Tools, Board, ESP32, and then I'm going to select the Do It ESP32 Dev Kit V1. Then I'm going to go set my port to COM5 in my case here. And then we're going to move on to the next step that says Open the Example Sketch. So I'm going to go to File, Examples, Basic, Blink. We're going to push that to the ESP32, and we should see a blinking blue LED if that worked okay. And as you can see here, we've got our blinking light, so that test is good. Now this next step in the Instructable tells us to go to File, Examples, Wi-Fi, Wi-Fi Scan. And this is a sketch that'll give us like a basic test to let us know that the Wi-Fi portion of this dev board's working okay. We'll load this sketch up, we'll push it to the board, and then we'll use this second part here that says Open Tools, Serial Monitor, and set our baud rate to 115/200, and we should see some serial console information back from the device. And I'm going to blur this out here because it's got some SSID information for myself and my neighbors, but if everything's working okay, you should see the SSIDs of any nearby access points, and that kind of validates that test. So the next step in the Instructable is going to have us making the connections on the ESP32 that we'll use to snap to the JST connector on the LED rings. So to do that, I cut 3 of the DuPont female jumpers in half, and I strip the ends, and you will see me solder those to the other half of the jumper that was provided with the kit, and then I will put a little black tape around that, and we'll be ready to try that out. So that's basically what's going to happen here as I'm speeding through this. And just wanted to reiterate, like the instructions say here, don't worry about the colors of anything. You really want to focus on what's connecting to what, because colors could be all over the place, especially if you start playing with other LED strips. So just keep that in mind when you're doing this kind of thing. I know this tape doesn't look great. I didn't have any small heat shrink. I would have done each individual leg, but I didn't, so this is good enough for just testing this out on the bench to show you guys how things work. If I was going to do a permanent installation, I would do something a bit different here. At this point, I made the connections as indicated in the Instructable that would correspond with the JST connector to the specified pins on the ESP32 board. After this, we need to get back over to the Arduino IDE so we can load some code. So the next thing we're going to do is find this fast LED library by searching for it in the library manager and clicking install. And once that installs, we'll be ready to go to File, Example, Fast LED, and look for this demo reel100.ino sketch. We'll open that up. We'll make sure the data pin is 5. We'll change this LED type to be WS2812B. Then I change this num LEDs value to be 128 to match the number of LEDs that are actually on all the connected rings. Then this was pushed to the ESP32. The USB was temporarily disconnected. This JST connector between the controller and the rings were connected. The USB was reconnected, and then this great light show began. I'll let this run for a little bit and fast forward so you can see a sampling of the different patterns it went through, but this looks like it worked just like a champ. The cool thing about this is too, you can see the code right there, so you can dive right into this and manipulate and see what else you can make it do, or look and see what happens when you change certain things in the code. That's the great thing about being able to experiment with this. I think it's really neat. Following forward with the Instructable, the next thing we're going to work on is wiring up this microphone. And we're going to go by this drawing, and then you'll see me go through here. I'm going to use the other half of those DuPont jumpers I used previously. I've already stripped the ends. I soldered those in place and used the DuPont female connector to connect to the specified headers on the board. So the next steps in the Instructable are directing us to get this piece of code from this repo. So I went and grabbed that. I just did it the dumb way. I just got the raw file and copied and pasted into a new sketch inside Arduino. The next steps tell us to go to Tools, Manage Libraries, search for and install Maguno link. That's going to be needed for this to work. Next, I worked on making the edits to make the file reflect those changes that were indicated from the Instructable. And I'm showing me doing most of it here, but then the actual disk space filled up on this machine I capture with. But as you can see here, in just a moment I'll show you where I did edit all those things to make them match. And here you can see I've got them all corrected, and I'm pushing the code to the device. And after that, we'll switch to the top-down bench view, and you can see if this thing works. Okay, there we go. Okay. Hello, how are you today? Ba, 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 boom. Let's find some music here. That's pretty cool how that works. You can see as I'm talking. Let's turn off the lights here. All right. So as you see, as I'm talking here, it is going around and round and round. So that would be kind of cool for music. I could also see this being a fun project for like a DIY speedometer or RPM gauge, and have it change colors during different various conditions. You know, maybe the red is only red at this certain range when certain conditions are met, or anything like that, or something to help you drive a little greener. I don't know. It might be fun for something to do with my old beater pickup truck I've got. I'm not going to mess with any of my new stuff, but it's very neat. Looking forward to tinkering with it some more. And here we have what I think could be one of the best things, and they've saved it for last, and that is WLED. Now I think that this is just a fantastic piece of software. It is tremendous. They have a great website that's full of all kinds of information. I highly recommend you go check that out. But the short and sweet of it is that this is a piece of software that will run on an ESP8266 or an ESP32. It gives you a nice, cool web interface to do all kinds of wild things with LEDs. It is super powerful, but also easy to use at the same time. The install is super easy now. You just go to this URL, hit install, select the serial port that your device is on, then hit install, and it'll just do its thing here. You hit install WLED right there. It'll ask you if you're sure. You hit install, and it'll just take off and do its thing. Now, if you have a reason or a platform where you can't use this web installer, I've got links to some previous videos of mine that show you, the old-fashioned way of just taking the bin file and using utility depending on whatever platform you want to push that to the ESP. With this new web installer, once you click next right here, it's actually going to scan your local Wi-Fi. Now, if you want to connect it to your home network, or if you've got like an IoT, kind of cordoned off SSID or something like that, maybe you want to connect it, this is where you would do that. You could, there's a drop down and you can pick the network, or the SSID rather, put in the password and hit connect. And if you're that advanced, you probably know what to do from there as far as how to get back to that device, either from a web browser on your network or from your phone or laptop, that kind of thing. But what I'm going to show you next here is how to get to the device when we leave it in the default mode where it acts like an access point by itself. So I'm just going to hit skip right here, and then we're going to switch over to the Android phone. To connect directly to the ESP, you're going to look for an SSID out there called WLED-AP, and you want to connect to that, and when it prompts you for a password, the default password is WLED1234. Or you can just scan this code that they have available there. Now, don't worry about the name or the password. You can change these later, and you may also want to change the channel. If you look at your other things, if they're set to auto or something, I don't know if this one has an auto select, but if you've got manual channel selection for your 2.4 stuff, you may want to take that into account when you set the channel for this thing. Now, when you access the WLED ESP32 or 8266, when it's in this mode, it'll almost act like it's, wanting to hit you with like a splash page, like something you might get from like an open or guest access network. So you just act like you're going to proceed with that, and it brings up the page, the main page to the WLED interface. Now, if you end up not being able to get to that, you can go to the IP once you associate, and it's just 4.3.2.1. And of course, that probably looks a little odd. That's not your typical RFC 1916 space. It's technically, I think, IP space that belongs to Google or that Google can use right now. But if you're just connecting to it, when you make changes to your lights and disconnecting, technically it's okay. But that's one of the things you can change when you log in and mess with the settings that I'll show you here in just a second. If you go into settings and LED preferences, we'll be able to make some changes like directed by the Instructable here. The color order is already set to GRB. The length I'm going to set to 128 here. And then I'm going to set the GPIO to 5 to match how this thing's currently connected up. And once I save that, you'll see that I can start making some changes to the colors and things like that. There are tons and tons of nerd knobs and color selections to tweak here within WLED, and there are a ton of pre-configured patterns you can go through, and those are super neat. And it looks really cool on this circular PCB that was sent in this month's box, but it's also pretty cool with string lights. I've been messing with some string lights this year. I'm going to overlay just a short clip of some I've been playing with in a room here at the house, and those could be really kind of cool for the holidays or for anything. Okay, that was the fun stuff. I want to talk about the non-fun stuff here real quick. One thing that seems to cause trouble or surprises folks or makes them think they have a problem sometimes, or it actually is a problem, is that they're not taking into account the number of LEDs, the brightness level that they have them at, and how much current that actually draws. Now, most of the stuff in this kit is pretty low draw, and we're actually pulling that power through the microcontroller board. If you can imagine, depending on your brightness, or if you had a ton of these things, that amperage rating, that current draw, is going to rise, and you could eventually surpass what a USB port is really wanting to give you from like a computer. Now maybe you could find a wall wart that would supply that power, but even then, if you're going through that microcontroller, you're probably going to surpass what's really ideal to do so at that point. But something like this website here, or any other way you want to try to figure it out on your own, figuring out a way to calculate your current needs for your mix of things would be good. And there are tons of great resources out there for more advanced, larger setups that give you great tips on how to do things. There's some great LED resources out there on YouTube. This Dr. Z's is one of them. Very cool. I'll put a link in the description. Another one here is looking at the cool things Cubicle Nate does. He's got some great demonstrations and really has some fun stuff there. The last is Resin Chemtech. He's from here at Indiana like I am, and he has lots of great LED related projects on his page. Very cool. Check him out. please do make sure to check out the description. I'm going to try to cram it full of great links on this topic, and if there's any kind of errata, that kind of thing, I'll make sure to put that in there as well. If this box looks like something that might interest you, looks like they still have some available as of the time of the recording. If this doesn't strike your fancy, check out some of the other boxes they've got. They've got some cool stuff out there at Hackerboxes. Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.